Good afternoon, everyone. I'm Dil Radhakrishnan. I'm one of the engineers here at MinIO. So today I'm going to be talking about some of the key innovations that we introduced as part of AIStor and walk you through live demo. Hopefully, we will be able to see successfully how these features work. So based on working with customers, some of the key things that we have noticed, all the customers face, some of the AI challenges are, how can they safely secure their private data sets and models? And after they do that, how can they get intelligence insights in the production environment? So these are some of the key challenges. And I've simplified the problem, but there are multiple steps involved to get to the final intelligent insight piece. So today in the demo, I'll show you how, using some of the building blocks that we have introduced, customers will be able to securely store their private data sets and models, and then make intelligence insights. And finally, even get a production-ready AI agent, which is able to interact with the data in your AIStor, still being secure. So let's start with the foundation. So in order to have your models and the data set secured safely, AIHub is the feature that we introduced. So using AIHub, all your private data sets and models, and even fine-tuned models, can be safely and securely stored in AIHub, which is directly storing all of these into the AIStor buckets. We thought about how to implement this, and we had a lot of discussion, and finally we decided that instead of us introducing our own way of doing things, let's adopt the industry standards. So Hugging Face has become like the de facto standard in the AI world. They are like the GitHub for all the datasets and models. Everyone from Meta, OpenAI, everyone publishes their models there, and everyone consumes it through Hugging Face. So what we have done here with AIHub is fully Hugging Face compatible, but still it runs in your on-prem. So what it does for your developers is they do the same API development, they do the same training or loading the data sets, fine-tuning the models, and when they're ready to push these models, instead of it going to Hugging Face, it is actually going into the AIStor bucket, which is private. And the entire ecosystem is fully supported. It's not just Hugging Face. You can now deploy your VLLM models using the AIHub that is already stored in there, or even SGLang, NVIDIA NIMs. Everyone supports Hugging Face in general. So let me just quickly dive into a demo of how this works, right? So for that, as a data scientist now, Jupyter Notebook is the de facto standard for everyone. This is where the ML engineers or data scientists do their work. So here, what I'm going to do is, in the left, you can see that we have two new categories. This is a custom plugin that we developed specifically for our customers who are going to use AIStor and AIHub, where they can automatically browse all the models that they have privately stored. So, and when they click on it, you can already see this is almost similar to what you will see in Hugging Face, the README page. They can easily see these are the models that is there, how to use them, and all of that is done right through the Jupyter Notebook without them leaving anywhere else. And same goes for the data sets. Now that you have this, the way this works is, as you can see here, whenever the client makes a request, what AIHub does is, AIHub first talks to AIStor and sees if this model or the data set actually exists in AIStor. If it doesn't, then it immediately pulls the model asynchronously from the Hugging Face hub and directs it back to the client. But behind the scenes, it's also caching it into your AIHub or the AIStor. So next time when the user comes and asks for the same model, it is directly pulling it from your AIStor without even touching Hugging Face. And so, for example, here, this is the model that...
So AIHub is effectively a database for these models and that sort of stuff? Is that?
Yeah, it's a repository for your data sets and models, but it fully is baked in and it's fully compatible with the existing ecosystem. So there is no specific learning curve for any of your developers or enterprise customers.
So what is the use case? Mm-hmm. Sorry, I'm not trying to be like disrespectful or anything, but like, what is the use case for that?
So what we have seen with customers, the use case is with the GenAI becoming like a rage these days, the customers, especially the enterprise customers, what they do is they want to use these open source models, let it be Llama or Qwen, as the base models. And using those base models, they have their own custom or private data set.
Train it.
They want to fine tune it using their own private data set for that specialized use case.
Okay, so you will be storing your fine tuned models in here.
Yep.
So it's not necessarily about like, saving your bandwidth from like, pulling the models from Hugging Face.
Yeah.
It's more about like, I need this fine-tuned model.
Exactly.
Okay, now it makes sense. Okay.
Yep.
Another thing, this AIStor, right? No, AIHub, sorry.
Yep.
AIHub, where this data is stored? It's on object storage?
It's all object storage. It directly talks to your AIStor.
Can we, like it have basically, like a point of access, right?
Mm-hmm.
Can we move this point of access to be different than other points of access, like dedicated for that? Different VLAN, different VRF, that kind of stuff.
Yeah. Okay. So in Hugging Face case, that is a single mono repo, whereas with AIHub, the way we have designed it is you can have multiple AI hubs. So one is specifically for your data scientist. They're only given access to the data sets. They're going to build the data sets, clean the data, and then make it ready for the ML engineers to come and do the model training. And then there will be a dedicated dev environments for the ML engineers who will do the fine-tuning and then push these models. And then finally, there will be a QA environment, dedicated AI hub, where the evaluation is done. And once all of these three have been successfully done, then you have a fully isolated AI hub for production, which is the one that you use for deploying your models and then doing inference.
And let's say the CI/CD pipeline that moves that model is integrated in this platform, and you need external tool.
That will be external, right? So each customers will have their own workflow. In some cases, customers will be like, I don't need this complexity. I'll just use the single AI hub, but I will version the model such that I know which models to pull. So that is up to the customer.
And the data versioning and model versioning, all that's automatic, or?
Yes. So since this is Hugging Face compatible, the way Hugging Face does it is through Git-based protocol. So you can create branches, you can do commits, build pull request and all of that. So automatically we are also compatible. That way it's automatically versioned. And even in some cases, if you're not using all of those capabilities that is baked into Hugging Face, you want to keep your work life simple, you can enable versioning in the bucket. And then when you keep pushing the new models or updating it, automatically everything, the object store is taking care, and you can retrieve your older models if at all that is the better one.
Yeah, so just to make sure, like, I understand it right. So what you have on the left side, that's basically like a Jupyter extension, right?
Yes.
Which you have in your Jupyter.
Yeah.
And you're using like Hugging Face, sort of like, because on the left side, like you can have the extension for the Hugging Face as well, right?
Yes.
But you have it for the AIHub.
Right.
So you're using the same methodology. That's your own extension, I guess.
Yes, it's our own extension.
Oh, okay. And that's connected into your AIHub. Okay. Yeah. And the AIHub is like literally behaving as a Hugging Face.
Right.
Like a replica.
So this plugin is not just for AIHub, but this is for the entire AIStor. So you will also be able to actually go and look at all the objects that is in your buckets, browse these objects.
Oh, I see.
So all of that. So this is like a full suite of development that without leaving the Jupyter notebook, everything can be done within the notebook itself.
Yeah.
Bringing the data to the developer.
Which is great for the developers, right?
Yep. So now the model that I downloaded here was actually pulled from the AIHub itself. So this is the model. And just to mimic that, once this model has been downloaded, let's say you fine tune it, and then finally you want to push it. Hopefully this works. Yeah. So once this is pushed, so basically what happens in a normal Hugging Face workflow is it is going to push it to the Hugging Face cloud. But in this case, what you will see is you will see the MinIO new model coming here. So you can see that we have the new model. So now next time when you're doing the deployment for the inference, you can automatically integrate it with the AIHub, and nothing has left your private cloud. And the entire workflow from a developer standpoint, it's still seamless for them. From an admin standpoint, nothing is leaving your cloud. So everything is safe and secure.
I understand you need a dedicated cluster to run that, right? Like a compute cluster.
For AIHub, you don't. AIHub is just streaming the bytes between the AIStor and
I'm saying, like, when you deploy the model against some data, you need a compute power that it's like...
Yeah, I mean, like, this, like, you can run this Juniper book on your laptop, right? So you just like literally pull it from the AIHub, deploy it on your laptop, and you can run a book.
Yep. Yeah, for inferencing and all of that, depending on the type of the model, you might need GPUs or CPUs. That infrastructure has to be set up by the customer. So once now you have these AI models and the data set secured, and you're able to deploy them and ready for production, the next phase is doing intelligence, right? So that's why we introduced something called as PromptObject. So one of the key things that we noticed as the GenAI started maturing is we are moving away from a put-get paradigm to a put and prompt paradigm. So what do I mean by that? So earlier when developers were dealing with data in the object store, there is a different kind of workflow that happened. So first the developer will come and download this object. It can be PDF, image, or whatever, any kind of unstructured data. And then after the object is downloaded, then they will go through some ML pipeline to do some kind of inference on top of this, or do some predictive analysis, and finally use it in the application workflow. So this has multiple flows involved, and there is a lot of frictions involved, multiple teams involved. So instead, what we thought is, what if we introduce GenAI capabilities right into the S3 API, which is the prompt object? Now, as soon as the object is already in the AIStor, when you do a prompt object, all you need to do is, along with this bucket and the object, you just need to tell, this is what I want to infer from this object. And behind the scenes, prompt object will go and interact with the LLM and get the desired results back to the developer. So from a application developer standpoint, earlier what used to happen is either you will have to build a RAG pipeline, irrespective of if you're using all the objects in this bucket or not. You will have to index them, and you will have to maintain a dedicated vector database. And finally, you will be able to do inference, which is a lot more expensive. But since this is more online and on demand, this is a lot more easier for the developers to adopt, or even AI agents to adopt, and quickly get insights from these objects.
So for the prompt object, you're doing embedding internally, or vectoring it, or what are you doing here? So
there is no vectoring or any of that involved. This is directly, we will extract the information from the object and pass it in a LLM-friendly manner. So if you're working with an image, the image will be transformed into base 64 encoding, and then passed down to a.
Yeah, but customers are going to have their regiment or regulations or something like that, and it's going to be thousands of objects in here.
Yes. Yep.
And you're going to provide a prompt object associated with it without vectoring. It doesn't seem like it's going to work very well.
In most of the cases, it does. So what we have seen is in many of these use cases, develop similar to what happens with get object, let's say. So the developers know this is the object that I'm going to interact with. In most of the cases, they are not going to interact with the entire objects in the bucket. They're only focused on a specific object for a given task. So that's why.
But the prompt is what directs what object to actually go through, and it's not necessarily clear which object in this regulations database is going to be the one that's going to provide the information necessary. The context, right?
Right. So there you will use a RAG pipeline, right? So when you don't know exactly which object has the data that you're looking for, then you will go and build a RAG pipeline, and you will know that, okay, this object has something. Then on top of that, you will have a hybrid approach where you can use RAG as well as prompt object to finally get to the desired results.
I'm just trying to understand where prompt object fits in this framework. Is it just providing additional context to the prompt? Is that?
It's providing additional context to the LLM without you building more complex pipelines, like extracting these informations, doing vectorization, and then maintaining all of that additional vector database. All of that complexity is kind of removed from you. So that is the key advantage here.
Okay.
And so it automatically is doing data transformation.
Yep.
You talked about grabbing image data.
Yep.
But also if I was grabbing text data, it's going to
so
automatically know how to tokenize it and what tokenizer to use.
Yeah, exactly. So we work with most of the unstructured objects like images, PDFs, videos. All of these are supported right now. So maybe I'll just quickly show a demo. That way it's a lot more cleaner. So before, like I showed you in the Jupyter Notebook, we already have support for the browsing the objects. So in this case, you can open any of these objects. And then we also have the prompt object integrated right here. You can be like, so here, what is powering this behind the scenes is the prompt object API. And additionally, what we have also done is you can copy the code to do the same thing, and then you can just go directly to the Jupyter Notebook. And all you need to do here is, instead of doing a get object, now you're doing, this is the bucket, this is the object, and now do this as a prompt is all the developer needs to do. And behind the scenes, we interact with the object store, get the object, and then transform it, and then pass it to the LLM and get the response back. So where this actually gets powerful, to answer your question, is, so mainly developers, what they do is, they want to transform an unstructured data into a structured data. So that way they can work with it and build more robust applications on top of it. So in this case, now mostly the LLMs are unstructured to unstructured data, but you can make it emit structured data. So here the developer can be like, this is the structure I want you to get me back when I do a prompt object. So once you have the pydantic object defined, all you need to do to the prompt object is you just pass that schema back to the prompt. And then when you trigger it, now basically what you have done is you have transformed the unstructured data into a structured JSON that you can now take it and work with the application or ingest it into your database and do analytics or any of that inside.
Yeah, but most of these things, they're going to want to do 1,000 objects. They're not just going to do one picture of an ID or something like that, right?
Yeah, so that is where I'm going to go to next. So the main focus here was prompt object should be only focused on a specific object, which is for the developers. But I also heard this feedback from our customers where, but I need to interact with multiple objects. How can I do that? So that is the next thing that I will talk about. But just to finish off, since prompt object works with OpenAI API compatible inference servers, we also introduced NVIDIA NIMs compatibility. NVIDIA NIMs is from NVIDIA. They have pre-packaged containerized LLMs that the customers can run in their environment. And it's a lot more faster to run specifically in the NVIDIA-based GPUs. So they offer two variations. One is hosted in the NVIDIA cloud itself. The other one is you can just get the containers from NVIDIA, and the customers can host it in their own infrastructure. And then they can integrate it with prompt object, and we will take the rest.
So your AIStor prompt object integrate with the infrastructure, with the Kubernetes cluster running on this infrastructure with NIMs, right? GPU.
Yep.
Okay, so this needs to be on external hardware.
Yes. So for this, you will definitely need a GPU.
And there is a chance that you can have MinIO on some servers, and in the same servers, you will have GPUs and use that.
So generally, we recommend compute and storage be two different things. Don't mix both the workloads, then it's very hard to manage. So in this case, AIStor will be a dedicated cluster, and the GPU clusters is running somewhere next to the object store. That way, it's a lot easier to manage both.
Because you said that the network is usually for the storage, right?
Mm-hmm.
For your storage, usually the network is a bottleneck, right? When you have NVMe.
Yes.
So you can assume that there is still some CPU unused in the clusters, in the storage clusters.
Yeah.
And so you didn't yet, at least, thought to move that, to mix that workloads together, because you still have some CPUs. If you will have dedicated network to that, then still you can use that NIMs GPU nodes inside your storage nodes.
We are also exploring if some of these models are maturing day by day. So we are also looking at like 1 billion models, which can be easily hosted in a CPU container. And then if your use case is dead simple, then go ahead and do that in your CPU. So there maybe you can think about that. But general recommendation from MinIO is don't mix the workloads of compute and storage. Right. All right. So the next thing, now that we have the model stored securely and then we are able to make intelligent insights, the next logical step for us to do is agents. So we were thinking about this a lot. Even when we were building prompt object, the main notion that we had was more than developers, we felt like AI agents will be the one that will be heavily using them. But at that time, tool calling or function calling was the way to integrate these with the LLMs. But now, Model Context Protocol was introduced by Anthropic recently, and every major provider like OpenAI, Google have already started embracing that. Even Microsoft has started embracing that. So what this does basically behind the scenes is it's just basically a protocol or a spec, and you just build your tools as a MCP server and just expose it to any of the clients that supports this MCP protocol. So as part of this, recently we introduced AIStor MCP, which customers have already, some of the customers have started deploying it and pounding AIStor like crazy with a lot of AI agent calls. So what basically this does is, I will just show you with a simple Claude desktop integration. So here, I've already have the AIStor MCP server integrated, and these are some of the functions that we support out of the box. So here I can be like, and then behind the scenes, Claude, what it's going to do is it'll interact with the MCP server for AIStor. It'll talk to the cluster, and it'll be able to list all the buckets that is there in my cluster.
So it's a hybrid solution, right?
Yeah, it's a hybrid solution. So the MCP server runs right next to the client, but the AIStor is actually running in your private infrastructure.
Could you go back to this prior that showed all the functionality and part of the, the demo actually. You had a listing of all the functionality.
Oh yeah.
That the MCP server supported for.
Yep.
Okay.
So we also have it in our GitHub, so you can look at all the functions that we support, and we keep expanding the capabilities day in and day out.
Can you show me how the delete works?
I don't want to delete since this is a production environment.
Oh, okay. That's exactly what I was thinking. Like, this can go quite unhinged, right?
Yes, it can go quite unhinged. So since I am, I don't want to show my creds, but since I am the admin of this cluster, what I have is, depending on the access key controls that you have, only those are allowed to perform certain access. And within the AIStor, the way the MCP server is built is, by default, it's only read-only.
Yeah.
It can only read buckets, objects, or whatever. It will not be able to do any create or delete operations. You have to force it to do that. So that will be done most probably by admins.
You're not brave enough to do the delete now?
No,
okay.
I'm not.
So maybe it's a naive question. When you have this MCP, right, integration done, the communication between the public cloud and local MCP gateway, I can call it like this, right? What kind of security matters are there? There are certification, SSL, TLS. What do you have there?
TLS certificates are required.
TLS.
Yep.
Okay, so it's a handshake between two TLS endpoints,
yes.
API endpoints.
Yep.
So, or through the VPN or through the direct connect, I don't need to directly present them, right, through the internet. I can hide them somewhere.
Yeah, so basically the client, wherever you are trying to access the AIStor, so if it has access to the AIStor cluster, then the MCP server will also have basically the access to that.
Okay, gotcha.
Yep.
Thanks.
So now going back to the question of, since we are only dealing with single object using prompt API, now with the MCP server, now what we have done with the AI agents is, now you can be like, I want to tag all the objects in this bucket, find what is there in this bucket, identify for each and every one of these objects, and then tag specifically for what is contained in those objects. So that can be done purely from a Claude desktop. And here, what I have done is...
Can you create a RAG database of all the objects?
You can, but in this...
the MCP server.
With the MCP server, with AIStor MCP server, you will not be able to. There is no need to do RAG because now you are able to do interactions with multiple objects at the same time and do the tagging and get interesting insights. So previously what I was able to do is...
So now you can use the...
You're not convinced, right?
Yes, he's not convinced.
He doesn't look like he's convinced.
There are requirements where RAG makes sense.
Yes.
There are requirements where it doesn't make sense. If you're just going through a number of tag photos and trying to extract information, that's not RAG. If you're looking at a compendium of Corporation X's PRs for the last 10,000 years, RAG is going to be much more impressive for that, something like that.
Yep.
Or regulations, that span volumes, RAG is going to be very intrinsic to something like that. It's not clear why you couldn't do something like a RAG with this, but you're creating the database is one aspect of the RAG and using it is another. So.
Yeah, so we did explore that strategy, right? So we did a RAG-based approach almost 2 years ago, and then we quickly figured out you have to be very opinionated on the RAG stack that you built, and the tech is emerging constantly and keep on evolving. So in the RAG pipeline, some of the bottlenecks that we noticed is, first, you need to do the embeddings. So the embeddings itself is highly opinionated. How do you do the tokenization? It has to be multimodal. It has to be able to serve for the specific user's needs. If it's not multimodal, how will you handle different type of modalities, and how will you do the search?
Yeah,
so now there was a
object storage. I think you have a lot of place for setting up metadata,
yes,
regardless to any model you will use. So this opinionation can be different between the models.
Yeah, it can be different between the models. Now, as soon as we get into multiple different models, now already the complexity of maintaining it and scaling it is going to be a really hard challenge. So that's why we wanted to keep things simple and opinionated. That way, if it's just at an object level, it's a lot more easier to deal with and still get a lot more insights for certain specific use cases. There are certain use cases where RAG will be definitely useful, especially when you're trying to make sense of entire objects in a given bucket and trying to consolidate and figure things out. There, maybe RAG makes great sense. But in many of the cases, what we have seen is, as a AIStor consumer, our developers, they mainly interact with a specific set of objects. It's not always the entire buckets or data at a whole time. So that's why we wanted to cater to that specific audience and target the solution to be scalable for those scenarios. So in this case, now for a given object, you will be able to do tagging for all of these images. In this case, I was able to ask what was there in the object 11. So this object 11 is animals.png, and it was able to answer, this was a lioness, appeared to be defensive and aggressive. And if we go back to the AIStor, AI data, animals.png, you can see this is the image that it was able to do. And now using that, what I'm also able to do is you can tag. So do a tag of all the animals that is present. And now what we are able to do is, using PromptObject behind the scenes, we are able to extract the information from the image, and we are also able to do the tagging automatically.
Okay, and then you can move that into metadata of the
Yes,
object.
exactly.
So this way you can somehow classify your data.
Yep. It's not just that. And finally, you will also be able to build visualizations of your AIStor cluster as well. So in this case, let me just quickly show this, and then let's move on. So here, the main thing that I wanted to do was build a visualization of my AIStor cluster. And using the function calls that we have exposed, it was able to get all the information and then build a clean dashboard. And it was also able to identify that one of the drives is failing. And as if you go here, you'll also be able to see that one of my drives is offline, basically. So using this agentic capabilities and the MCP server, now you will be, as a admin or even as a AI or application developer, you'll be able to do a lot more interesting things.
Yeah, it's a clever way. You didn't build it yourself. You just use what is on the market.
Yeah. So finally, now that we have all the building blocks, from storing the models and then doing insights on top of that, and then finally also doing agentic capabilities, now you will have insane amount of workloads that is hitting your GPUs. So in order to address that specific needs, we are now doing AIStor integration with the NVIDIA NIXL. So one of the bottlenecks is the KV cache. When you do inference with all of these LLMs, the model needs to do a pre-filling of KV cache and then do the tokens, transform them, and then finally do the inference. When multiple of these clients are interacting with your inference server, immediately this can get out of hand. And the GPUs are constantly churning and churning, and they will run out of GPU memory. So in order to address that specific needs, we also are working with NVIDIA to bring in object native KV store. That way, you can easily offload some of those already historical conversations or historical tokens that has been already computed into your object store. And then whenever it's needed, NVIDIA NIXL can automatically pull it and give it to the inference server.
I always thought the KV cache was very transient with respect to the prompt. Is that not the case?
In some cases, it is true. In some cases, though, you are working with a specific context. For example, in Claude, if you noticed, they have a dedicated section called as projects. In the projects, you can upload a bunch of documents, and that is the pre-filled cache of context. So that KV cache, you can constantly have it in the GPU memory, or if the customer is not interacting, then you can offload it to ObjectStore. And then when the customer is coming and interacting, then you can load it without doing the compute again.
So would you consider some sort of a size threshold or a time threshold for whether to use an object KV cache versus a GPU?
So in this case, NVIDIA NIXL automatically does it. There is a timeout internally happening at a server level itself. So it depends on VLLM or NVIDIA Triton. They will be like, okay, this has not been used for a while, so let me offload it to RAM or ObjectStore.